You can create an AI product that will impact, millions of people, literally millions of people, and you don't have guidelines to follow, even from not necessarily from a legal perspective, but even from an industry perspective. And so it's bringing forward all of these little, quite big now conflicts about what does it mean to be reproducible? What does it mean to be, open science? How do we make it really possible for AI to be transparent?
Hi, I'm Stephanie Tumampos, and you're listening to Down to Earth, the show where we talk to incredible geoscientists about their science and its impacts on our planet. This season, we're speaking to a wide variety of folks to investigate all things open science. The first Earth observation satellite developed by NASA was a Polar Orbiting Television Infrared Observation Satellite, or TIROS, in 1960. It was responsible for providing a view of Earth's cloud patterns from space and was useful in both civilian weather forecasting and in planning military maneuvers. Fast forward 60 years later, we have more than 900 Earth observation satellites collecting terabytes of Earth data daily. What do we do with all this data, especially when it can be the key to solving our climate change problems? The answer people are currently looking to is machine learning, or artificial intelligence as it's known by the general public. AI is a powerful tool that can certainly help us process all the data we're collecting about our planet. Yet, as much as we say AI has advanced technology, there's a lot of room for improvement. In the earth sciences, processing huge amounts of data using AI requires time, of course, but it also requires the use of extensive resources that can further exacerbate climate change. Materials to build and run AI systems must be extracted from our environment, and with AI consuming so much processing power, we need large data centers to store the data required for running AI systems. In addition to the environmental challenges AI presents, it also highlights some critical social challenges. For example, facial recognition algorithms are raising important questions around the ethical use of AI. Despite growing concerns, AI is not going away anytime soon. So the question becomes, how can we improve AI approaches so they become more sustainable and ethical? It's possible that open science might help in this area. So today, I'm speaking with a researcher who will help us shed light on addressing the closed nature of AI. This episode of Down to Earth is brought to you by the IEEE Geoscience and Remote Sensing Society. The GRSS is a community of passionate researchers and practitioners who are working to benefit society through their science, engineering, education, and applications. This year, GRSS is excited to collaborate with the NASA Transform to Open Science initiative to celebrate the Year of Open Science with a whole Down to Earth season devoted to this very topic. To learn more and get involved in their year-long events and celebrations, visit science.nasa.gov and search for Open Science.
I had a bit of a quarter life crisis maybe a couple of years ago. I was actually working in financial AI, and it was really interesting, I guess, from a puzzle solving point of view. But then at the end of the day, I was like, I didn't have the fulfillment. I found that there's an institute in Montreal here called Mila, and they were hiring a postdoc to work on AI for social good initiatives. And so essentially, I convinced them to hire me. And for 2 years, I worked there. And that's when I worked with the United Nations and other local NGOs, and essentially kind of on the AI for social good space.
This is Dr. Sasha Luccioni. She's a research scientist at Hugging Face and a member of Climate Change AI.
When I started out in AI, you could train a model on your computer. You didn't need huge amounts of compute in order to be part of the scientific community in terms of language models. Nowadays, it's harder and harder to do that because these models are so big that you need a computing cluster. The barrier to entry for people from non-privileged spaces is getting kind of ridiculous, honestly. And then I realized that open science is a way of helping people get involved who otherwise wouldn't get the opportunity to.
Sasha uses her skills in AI to harness its potential for addressing climate change, as well as to figure out how we can get ahead of AI's social, environmental, and ethical implications through policies and practices that help make AI more open. To start, let's have a clear definition of AI, because this is so important. There are a lot of definitions of AI, and the first definition I encountered, there was a negative connotation with AI. So let's have a clear definition of AI. What is AI?
So yeah, it's really hard to give one clear definition. I guess it depends on who you're talking to. Some people really see it as giving machines the ability to think, to reason, to act. Others see it as a way of mimicking human intelligence via machines. I'm more the second side of things, and I would add to that. I think that AI is kind of a way of complementing our own knowledge, our own actions in the world with technology. So I don't think human intelligence has anything to do with it. It's more like defining ways for machines to help us be a better society, a better community, what have you. So in my own work, it's an algorithm, so a mathematical model that takes something as input, takes data as input, and produces some sort of output. The output can be predictions, can be actions, can be words, images, but essentially it's really an input-output function.
As someone who studies the social and ethical implications of AI, can you give us a really brief history of AI from this perspective? What have we missed through the decades of AI development?
Well, yeah, actually, artificial intelligence has been around since the 1950s, so it's definitely not something that was very recently invented anyway. It came from an academic perspective, really researchers, kind of fundamental researchers from mathematics, from computer science who came together and wanted to make machines think, more broadly speaking. And so for decades, a lot of the work that was done in AI was seen as really fundamental. So, making a better function, making it more efficient, et cetera. It was really focused on kind of the fundamental mathematical side of things. It was seen as very, very detached from society for decades. And now AI systems are increasingly becoming more and more deployed in societies. And so essentially we have the ability to, scrape the whole internet and train a language model. We have the ability to scrape the whole internet and train an image classification model. And so in the last 5-7 years, we've really seen more and more, we've seen situations where training and test or deployment don't make sense because real life doesn't look like the internet. And so this is when we've seen really these large questions about how do we ensure fairness? How do we track and kind of predict when models are making false predictions, or when there's like a drift, kind of a divergence between the data that they were trained on and the data that they're being deployed on. So more and more we're coming to face with these really very concrete questions that we don't have the answers to.
When you say models don't make sense in the real world, what does that mean? Can you give an example? Are you referring to ethical considerations?
Not necessarily, honestly. I mean, ethical considerations is really one of the issues, but for example, there was a case a couple of years ago that kind of stuck with a lot of people. A well-known tech company took a bunch of CVs of people they had already hired, like essentially their employees, and they trained a model to predict whether people were a good fit for their company. And the system was deployed and it had relatively good results. And then like a couple of years later, someone realized that as soon as a resume had any kind of female connotated terms, either like a college or like a female sports team, the word women, the CV was being rejected, or the resume was being rejected. And the thing is with an AI system is that you don't necessarily know what it's missing. So you kind of have the things that it's flagging. So it's flagging potential candidates, but you don't really know what it's missing. There's a lot of aspects to this. In some cases, it's really like a difference between the data that a model is trained on and how it's being used in the real world. And in other cases, it's being used in the same way that it was trained. But the fact is that society or technology, for example, is so biased that it starts having these behaviors that weren't predicted, right? It wasn't meant to be very sexist, but it turned out to be very sexist.
So AI in many ways has the potential to reinforce current bias in the real world.
Exactly. It all depends on the data that we give it. So where research comes in, where science comes in, is understanding our own biases and the biases that we encode in our own data, right? Like depending on what the role is, depending on what country you're deploying this model on, there's like a lot of kind of very contextual things that need to be defined. So that's why it's so hard to do general bias research, because there's no such thing as general bias. It's a very contextual bias depending on where the model is used.
So one of the things we need to do in AI is to be aware of our existing contextual biases. There are also other ethical considerations surrounding AI. What are the main debates about AI right now?
So AI moves so fast that it's there's a lot of things going on at once. But for example, right now we're really have a time of reckoning in terms of things that AI should and shouldn't be used for. So for example, things like facial recognition, things like emotion recognition. Should we be doing predictive policing using AI? Should we really be giving law enforcement agencies or governments access to these algorithms? So we're having a lot of discussions about norms. And then there's also a lot of debate about consent in terms of people whose data are used for training the algorithms. That's been a big sweeping under the rug situation for the longest time because companies were scraping data from the internet, from social media, and essentially using it to train their algorithms. And it was kind of a fair use situation. But now more and more, there are court cases. There are, really people who are challenging this status quo of, well, if your data's on the internet, it could be used to train an algorithm. And I guess from the research side of things, there's a lot of work being done in terms of interpretability. So understanding AI models better, how they work, how they fail, what characteristics they use to take their decisions. So there's really kind of several topics being pursued at once. And what's interesting about AI is that I think we've all realized it by now that it's not just a technical issue. It's not just a computer science field. There's legal aspects, there's societal aspects, there's all sorts of philosophical questions that come up. And we can't just pretend that, we wrote an algorithm and move on. We have to consider the legal aspects. We have to consider the ethical aspects. And this is all coming together right now.
It's very interesting to hear that. So in your view, how does AI intersect with the open science movement?
So it's interesting because currently the development of AI systems is really, is rooted in two cultures. On one hand, academia, the academic side of AI, has been open from the start. And I feel like we started kind of on the open side. Now we have been drifting towards the closed side for a couple of years now. And now we have a lot of companies whose whole business model relies on keeping their AI models closed source. And so now we have kind of a crossroads and a tension between keeping AI open source, open science, and making products out of AI and not sharing that secret sauce. And so there is a bit of a tension there. For example, You Only Look Once was a very famous image classification model that was very, very good. And the researchers published it. And then essentially, because it was open and because it was a permissive license, companies could use it under the hood and then they could use it for things like drone strikes, right?
Whoa.
So, yeah. And we also have a very severe reproducibility crisis in AI in the sense of that when people publish results, other people can't replicate them because it will depend on a very kind of small random seed or something that isn't necessarily shared. So also the product side of AI and the fact that some of the most kind of popular and most well-known models are actually closed source, we don't know how they work. And so we're still figuring it out.
Mm-hmm. So we need to start opening up transparency around the use of models, right? Especially in the industry side. Am I correct?
I would say yes, but there's a really big debate about this because, companies have the right, I guess that's kind of their prerogative to have proprietary models, to have proprietary data, to have proprietary, like all sorts of stuff, right? They have their secret sauce and that's how they make money. And that's how it's always been, right? Like, I don't know, KFC, you don't know the recipe of KFC. But the thing is that we have the FDA, we have all sorts of organisms, institutions that are there to make sure that, your food is not being poisoned. For AI, we don't currently have that. I think what will help is oversight and auditing. So a lot of people, a lot of very great researchers are working on the auditing side, how to make sure that we have procedures to follow, but we still have this gap between policymaking and tech.
What Sasha has shared with me about the controversial uses of AI makes me nervous. Knowing that data scraped from the internet can lead to bias in AI models is frustrating, but it's almost worse to think that researchers who embrace open science are seeing their open algorithms taken and used by companies for nefarious purposes, like facilitating drone strikes. There truly is a very, very dark underbelly to artificial intelligence. But what do we do about it? As Sasha mentioned, audits, regulation, and policies might be the answer. But as she pointed out, will they actually work? And with the barrier that policy development is a slow process, will we ever be able to stay on top of regulating a technology that is changing at breakneck speed? We'll find out after the break.
Are you a student or recent grad ready to reach your full potential in the geosciences? Then you need to join the Geoscience and Remote Sensing Society. With over 75 chapters in 94 different countries, you'll connect with a diverse community of professionals, experts, and advisors who can inspire your science and help shape your career. Find support and fellowship as part of our Young Professionals Network. Advance your skills through our GRSS schools, student travel grants, workshops, and more. Be at the forefront of geoscience research by joining our technical committees and network with geoscientists from around the world at IGARS, our flagship conference. Our incredible international community is ready to welcome you. Learn more and get connected today by visiting grss-ieee.org.
Welcome back. Today we're speaking to Dr. Sasha Luccioni, research scientist at Hugging Face and member of Climate Change AI. Sasha has highlighted a number of areas where people are starting to question the ethics behind AI. From the fact that AI data processing often happens in a black box that researchers cannot explain, to companies who are taking open AI and using it for ethically questionable activities. There are a ton of questions that need to be addressed if AI is ever going to align with the open science movement. But if ever there was someone to talk about how to do this, it's Sasha, because she's at the forefront of figuring out policy and practice solutions to these closed AI conundrums. Okay, so you mentioned the need for policy in AI, but you also hinted that there are challenges to this policy development work. Can you elaborate?
We're starting to see audits. We're starting to have, the government or some branches of the government asking, how does this work? How does this technology work? But the issue with that is that even if someone were to open source, for example, the code of their AI model, it's so hard to interpret because these are really black boxes. So unless they're really experts in AI, it's really hard for them to understand what's going on. And is this model biased? Is it working the way it should be? Is it a danger to society, customers, consumers? And honestly, like a big part of this is awareness and connections with policymakers. I mean, there's such a big gap in terms of like the terminology, the technology. Like it's really hard to bridge it because once again, AI is moving so fast. Is that they'll have a policy brief or a workshop, say now about language models, but now we're doing text to image models, and then by the time they catch up, it's going to be text to video, and we're going to have deep fakes, and we're going to have whatnot. And so it's like it's moving so fast that it's hard to legislate it, but it's so important that legislators and members of the government understand how this technology works in order to properly create oversight mechanisms.
What about improvements to the ethics surrounding AI? What's happening here?
So ethics is definitely catching up. I think the crux of it is evaluation, and that's why I'm like obsessed with evaluation, because it's something that people kind of find boring typically, because everyone likes training models. They like doing cool new stuff and cool new model architectures and saying their model is bigger than the rest and whatnot. And I mean, that's great, but evaluating models is so interesting because you can't measure what you can't evaluate, essentially. So depending on what measuring stick you're using to compare your models, you can be like, well, my model is better than yours because I don't know, what matters to me is efficiency. And you can be like, well, my model is better than yours because what matters to me is, I don't know, precision, right? Or fairness across X categories. And so for me, focusing on evaluation and focusing on developing metrics, developing data sets for comparing models is really important because, academia and industry and I guess, for example, nonprofits don't have the same things that matter to them at all. They don't have the same values. They don't have the same measuring sticks. And we're starting to see evaluation approaches that are socio-technical. And that's really, this really novel and very exciting because for once, it's not just, 97% accuracy. It's really like, we have aspects of fairness, we have aspects of efficiency, we have aspects of, taking into account the context of deployment. All of that comes together, and socio-technical work is finally becoming, accepted and kind of cherished in certain subcommunities of AI.
To clarify for our listeners, socio-technical evaluations are evaluations that take into account both the societal and technological aspects of an AI product. For example, this type of evaluation might measure the AI system's quality and accuracy while also assessing the impact the system is having on the people who use it. It's essentially looking at the AI system's whole picture, to describe the complex ways humans interact with technology and ultimately influence society. Now back to the interview. Okay, so you are part of an organization called Hugging Face, which is focused on open source machine learning. Tell me more about this organization. How is it helping to bring more transparency into AI?
Well, Hugging Face is a startup where I work, and the mission of the company is to democratize machine learning. And so the idea is that everything we do is open, all of our code and all of our models. And now what Hugging Face is trying to do is to create like a central repository where people can upload their models, choose what license they want to attribute to the models. Do they want it to be used for like commercial purposes or non-commercial purposes? You know, who does it belong to, et cetera, et cetera. And the idea is to really make AI more democratized, so to lower the barrier to entry via open source and open science. And that's why I like firmly believe in Hugging Face. I mean, as an organization, because the mission is really to help people get involved and to like we have all these sub communities like the sustainability community. We have all sorts of like small niche communities forming now who are using Hugging Face as a hub for sharing their models and making them more accessible, broadly speaking.
So, do you think Hugging Face may be a model or a basis for moving forward on evaluation frameworks and best practices in AI?
Yeah, actually, we recently created a library called Evaluate, Hugging Face Evaluate, and it was really fun, actually. I really loved working on it because we took a lot of the existing metrics that people use for evaluating machine learning models, like accuracy and precision, and we also added some, non-standard ones like efficiency and some bias and fairness metrics. And essentially, we're trying to bring them all to one place. And so now we're trying to make it like as seamless as possible to just like essentially like run one line of code and then have your model be evaluated from all these different perspectives. And so evaluation is like a key part of the mission as well.
And you're also doing some standards development work in other areas, right? So can you tell us about this and how you hope it might support transparency in AI?
I'm part of the organizing committee of the NeurIPS conference this year. It's one of the biggest machine learning AI conferences. And, we have, for example, now a checklist that authors have to fill out when they're applying. I mean, if they're submitting a paper to the conference, and they're supposed to share their code, they're supposed to share everything that's necessary for reproducibility. And the reviewers are supposed to check this as an actual condition to acceptance. And it's really, sometimes it creates friction because people will submit coming from industry and they don't necessarily have the right to share their data, for example. And in other cases, in order to reproduce the model, you need to train it for 3 months because models are so big now that you need that much compute. And so just from like a community perspective, developing these norms and starting to enforce them, for example, via conferences like NeurIPS, like this will start percolating into industry and we're going to have best practices because currently it's kind of a, once again, like throwing pasta on the wall and see what sticks. And honestly, like when I started out in AI, like we spent a fair amount of time like checking our data, making sure that kind of the data that we're using makes sense, that the quality is there and stuff like that. And as these data sets got bigger, we kind of said, well, now the data set's too big, so we don't really know what's in it. But I'm hoping that we're going to go back to quality and to kind of developing methods or using the existing methods, honestly, to analyzing the data sets. And I hope that multidisciplinarity is going to keep being rewarded because it's there. So I'm hoping there's going to be more of that because as far as I'm concerned, that's the only future of AI when we start connecting the dots and making it more of a socio-technical area rather than just a technical one.
Yeah, agreed. So what is your advice for other scientists wanting to make their AI more equitable and transparent?
I think that it's important for us to be kind of honest and self-aware of, what we consider important as scientists. And in order to really, for example, make AI more reproducible, to make it more efficient, to lower the barrier to entry, we need to start like reflecting upon the way we do things and then seeing whether kind of our actions match our intentions. And there's like a really well-documented phenomenon that's called the intention action gap. And essentially, like if you ask, especially kind of younger people, you ask them, climate change, and they say, yeah, it's a big problem. Like we definitely care about it. It's really important, biggest problem of our time. And then if you ask them, like, what are you doing concretely to fight climate change? They're like, oh, well, I recycle, like I still fly 15 times a year, but at least like I try to separate my plastic from my paper or whatnot. And so I think that like this is the case for a lot of human behavior, and machine learning or AI is part of this. And so, if we want to be more reproducible and more accessible, we have to start kind of auto-reflecting and being like, okay, but is the way I practice science coherent with the way I kind of perceive science? And so that's a hard challenge to face, but an important one.
So in my master's, we built an AI model and fed it air pollution and urban landscape data. We then looked at whether or not the AI found a relationship between these data sets. Surprise, surprise, it did. So we were able to test the AI model to see if it could predict this relationship over time. While the model needs some improvement, there's definitely potential to use it for predicting air pollution levels in the future. My point here is, when we were building this model, we weren't necessarily thinking about the ethics behind it. But now that I've had this conversation with Sasha, I'm starting to wonder, what are the human implications of my research? For example, if we are able to predict high air pollution levels in desirable areas of a city, will that bring down housing and condo prices in that area? Maybe it won't, but it's something we need to be thinking through as we conduct our research. As Sasha pointed out, it would be helpful if the AI field had policies or guidelines we researchers could follow as we start to incorporate AI into our work. And we definitely need diverse voices to participate in developing these policies so they are as open, ethical, and practical as possible. In fact, this focus on enabling more accessibility in open science is a recurring theme this season. How we do it looks different for everyone we speak with. For folks like Sasha and Yuvi, this is about lowering the barriers to entry through open tech. For Sativa, it's honoring community sovereignty to data and research. For Demetrius and Leia, it's about creating pathways to invite others into open science, and then providing resources that continue to support their participation. In our next episode, we'll speak to two researchers who are using science communication and the FAIR principles to support access in open science. Want to learn more about Sasha Luccioni and her work?
I'm on Twitter, Sasha MTL. If people are interested in AI and the climate crisis, is the website climatechange.ai. And we've got a lot of kind of explainers and interactive summaries and things like that people can go explore in order to see how AI can fight the climate crisis.
Be sure to follow and rate us on Spotify and Apple Podcasts. And connect with our sponsors at IEEE_GRSS on Twitter and Instagram, and IEEE Geoscience and Remote Sensing on Facebook and LinkedIn. This episode was produced by Nicole Bedford from Nicole Bedford Films with help from me, Stephanie Tomampos. Graphics and design by Mylene Briggs of Killa Media. And a special thanks to Yvonne Ivy Parker and Keely Roth for their support. I'm Stephanie Tomampos, and you've been listening to Down to Earth.